So let's begin. This is Wilberforce's CfEM presentation. So let me slideshow, come on. Hey, there we go. How does teachers and students' use of Geogebra support the understanding of geometry? Now, if you remember when us Action Research people met up in November, I was very excited for this because it's something you can measure. It's something transferable that you can take to other places across, the UK. And we really wanted to see if Geogebra would improve things like engagement, student understanding of, geometry, essentially. So in plain English, how can one effectively use Geogebra to improve GCSE mathematics attainment? That's pretty much what we were trying to investigate if COVID-19 didn't get in the way, but it is what it is. So I'd first like to outline our presentation structure. 4 parts. First part, the motivation behind why we chose Geogebra. Number 2, the method, how do we do it, or how are we going to plan on doing it? The third, the results of the few results that we had, again, because of COVID, that's what I'm blaming. And then 4, the conclusion from those results. So first off, I just wanted to discuss the introduction and motivation, a bit about the problem we're trying to face. So we're all sort of gathered here trying to improve GCSE research results at the end of the day. And I've got some quite shocking stats here. National pass rate of June 2019 GCSE mathematics research examinees was 21.2%, a 1.4% negative point shift on the previous year. And now that we've seen this QR code, I would like to mention that there's a few dynamic QR codes in here, which will link to certain files. I'll talk about them as we're going. But basically, they are valid for 6 days. So if you want to scan now, have a go at it. The PowerPoint will be on Padlet as well, I believe. But just so you have a few more files or whatever. But these are just sources at the minute. I'll let you know when we get some juicy files going. And I've called this slide a Hull-Lenzien exacerbation. Kind of sounds a bit weird, but there's 2 things Hull's famous for: chip spice and being in the sun's worst places to live in the UK. And unfortunately, where Wilberforce lies is in an economically deprived part of Kingston upon Hull. It's pretty much known that Hull is very much deprived, and with that becomes hereditary apathy, and sort of problems that we face with us being in that certain area. So we really need to find a solution to this problem that we see ourselves facing, in that kids just aren't engaged, they aren't working hard enough essentially, and they're not getting the grades we want. So what tools can we use? Well, Geogebra, we give it away. 3 reasons we've chosen here. First one, accessibility. Second one, adaptability. And the third one, engagement there. I'll discuss each as we go. So the first one then, accessibility. Geogebra works on all sorts of different mobile phones, tablets, computers. I bet you even a brick Nokia could run it. But it's also available in multiple languages, so it's accessible even to some of your EAL kids, but definitely it's accessible to a lot of people. Again, especially for us where we are, there's not a great money barrier to be able to access Geogebra, so the kids could maybe do a bit of home learning there as well. Reason 2, it's adaptability. Now this is really for the learners that we can talk at all day and they still will listen to us. I think we can all relate to that, can't we? But maybe Geogebra might provide a different plan of attack, a different angle to approach a different angle to approach geometry, and maybe get them engaged. Who knows? We're just finding these things out at the minute. Well, an interesting article that I read by Professor Kutlucker, I hope I'm not butchering that, I probably am, said that he saw that Geogebra actually encouraged kids to engage, share ideas, peer mark essentially, and that's what we want to achieve. We want to achieve, high levels of engagement, high levels of conscientiousness within our students. So with that out of the way, Geogebra, excellent. The problem at hand, we've identified. Our next part is the methodology, the method. What do we do? So the idea of sort of testing any sort of tuition method and whether it works, you've really just got to do a pre-test on something, give them a block of teaching, and then a post-test. The pre and post test need to be fairly similar to try and eliminate those variables. But essentially, that's all we're doing, a pre-test and a post-test with a bit of GeoGebra tuition in between. But we also wanted to find out whether our teachers were confident in implementing this GeoGebra tuition, making sure they're confident in using GeoGebra themselves, so we can get this investigation off to a good start. So our outline then, I like my bullet points, even though there's no bullets here, forgive me. M1 is our teacher questionnaire. So this was all about how we could investigate whether teachers in our partner schools were confident using GeoGebra. Our second part of our method, the GeoGebra tuition, where if the teachers weren't confident, we'd go in and essentially show them how to do it, the free CPD on their end. Third part is the pre-teaching assessment. Part 4 is where we teach the kids using GeoGebra, using certain applets and things like that. And part 5 is our post-teaching assessment. So like I said, good way to test tuition method, bang, pre-test, post-test, see if they improve. And I'll describe each one as we go. So here's one of our dynamic QR codes, our cheapskate. So I've got the free trial of this QR code generator things. These are valid for 6 days, I believe. But yeah, you can scan that, have a look. I don't know if any of this is on Padlet. I know the presentation is, but any of the other bump that comes with it might be. I don't know. So we selected the questions to be as broad as possible. So this is where we gave our teachers a Google Forms document to say, okay, how confident are you with it? Do you feel confident using it in front of students, that sort of thing? I'll get into each question as we go through the results, because I think that's more beneficial. But just so you know, you're aware, this was our starting point of teacher questionnaires. And so if we maybe saw a gap of knowledge, a little bit of lack of confidence, that sort of thing, we would send one of our teachers to one of the partner schools to demonstrate how to use it and how we want them to use it in terms of this investigation. So like I said, a bit of free CPD, not much to really discuss there, but it's still an important point of our investigation. Next part then, the pre-teaching assessment, and I'll go through the questions in a bit, but this is just exactly as it says, the pre-teaching assessment. So before we do any sort of GeoGebra tuition with the kids, give them a test to see what they know of geometry already and see if they're any good. So there's the dynamic QR code there, again, relevant for 6 days because I don't want to pay for the premium service, just got the free trial. So if we have a look at this, look at that, animation skills. This is our pre-teaching assessment. So 3 questions, pretty basic. First question, transformations. Second one, straight line graphs. And the third one, angles and polygons. So really the cornerstones of coordinate geometry, angles, that sort of thing. We chose these because we found that there was plenty of good applets, GeoGebra applets, so little GeoGebra programs that you might use to really suit these questions. So yeah, they're there. You can scan the dynamic QR code if you like on the previous slide. To see the PDF file, I believe. Next, our GeoGebra tuition. So I don't have any links here. To be honest with you, I completely forgot to put the QR codes in because I'm a genius. But here's the sort of GeoGebra applets we'd give the kids. So one on angles, one on transformations, one on equations of straight lines. So fairly basic, we're not overloading the kids, but definitely we are putting those applets to good use, making sure that each of those applets applies to each of the questions on the pretest. But links to all of these applets can be found on our report, which is on Padlet, and I'll show you the QR code at the end if you want to check out the report rather easily. Next, our post-teaching assessment. It might look exactly the same. It might be I might have just copied the slide, who knows. These questions are almost identical to the pre-teaching assessment, and I'll show you them. Again, another dynamic QR code there with our Math CFE logo in it. That's fancy. So again, stick animations here. Pixar should hire me. Exactly the same. Transformations, straight line graphs, angles, and polygons. Exactly the same topics, but slightly different questions. And that's what we wanted to do. We wanted to make sure that there wasn't too much difference between the pre-test and the post-test. Again, to try and eliminate some of those variables of kids finding certain exam question styles rather worrying, let's say. But yeah, pre-teaching assessment and post-teaching assessment almost identical, but the questions are different, but the layout's very much the same. Next, our results and analysis. So this is the cop-out section where I say COVID-19 ruined everything. So apologies in advance. So yeah, this is my excuse slide. It is without doubt that COVID-19 has affected the progress of this investigation. Basically, I've got some results, well, we've got some results. I'm going to break them down, but yeah, COVID-19 wasn't very nice for our investigation. So here's what I would expect to get, right? So results from each step of our method, and this is just exactly the same slide that we've seen before. Only I'm going to rule out the things that we don't have results for because COVID-19 ruined it all. We have results for our teacher questionnaire and our pre-teaching assessment. So these two things are still valuable information. And I'm going to try and extract as much useful information as I can from these two things. So our teacher questionnaire, again, I'll put that dynamic QR code there so you can just bang on your phone. Job's a good one. And I'm going to discuss the answers to each question of this teacher questionnaire, just so you've got a bit of a flavour of what teachers in our partner schools thought. So the first question we asked, do you use any of the following apps to support delivery of geometry in the classroom? Luckily, nobody lied to us and said daily, but we definitely have some interesting results here. Definitely, some people are familiar with Geogebra and Desmos, which is good. But we really want to see that high. We really want to see those purple bars across the board go down, because the more sort of programs, the more tools we have to teach the kids, I think the more variety and the more engaged they might become. That's just speculation on my part, though. What's interesting about this, we also asked about Wolfram Mathematica and MATLAB. These are quite advanced mathematical tools, often university level statistics, that sort of thing. Maybe that could be an avenue investigation. Maybe kids will become interested in Mathematica and MATLAB. Maybe, who knows? Next question then, how confident are you in using new technology in lessons? What I thought was cool about this is we've got 55% saying fairly confident. And fairly confident is very promising to me, because all it takes is not much resources to really make those teachers confident in using what they're using. And that's really great to see. The thing that's not great to see is that 5% at the bottom saying I would avoid using new technology in lessons, which, you know, fair play to them. If they don't want to use it, don't want to use it. But 95% are saying I'll try it, which is really encouraging to us. It's sort of what I've written there, really. Regardless of whether we're doing this CfEM stuff or whatever, we should aim to instill confidence within teaching staff no matter what. I think that's key, really. But moving on, nice pie chart here, very colourful. If you've not used Geogebra before, what are your reasons? One thing that I've picked out here is 40% of our educators said the Geogebra user interface looks too complex. And that's kind of worrying to me, really, because we picked Geogebra rather than Desmos, because Geogebra works really well on mobile platforms, and it's not too different to its web software, so to speak. So it's really sort of, I thought it was easy to use, but again, it just shows that that's maybe just a barrier, but we can overcome that barrier if more teachers need that CPD in Geogebra. Again, another bar chart. What kind of support would you require in order to use Geogebra more often in the learning environment? 90% of our survey population said they wanted more CPD in this area. And that's really cool, because what it tells me is Geogebra is very much untapped in the classroom. Not many people are using it, which maybe they should. And if they are, we want to see results of student progression, student attainment, that sort of thing. But this 90% figure really speaks volumes that we're onto something here, and it might be a good investigation. Then I've got results for the pre-teaching assessment. I apologise I couldn't fit them all on. Just for format's sake, I've just put 3 students' work on there. The 3 questions answered there, I appreciate they're not very clear, but I put these up there just to really emphasise what we all know. GCSE research students really struggle with confidence, conscientiousness, and engagement. And that's just another piece of evidence to say, look, we need to do something. We're definitely outlining that problem there. But more so, Geogebra might be the answer to that, which is really cool. Next, our conclusion and evaluation, the segment where we ask ourselves, can Wilberforce salvage anything from this experiment? I think so, because we've definitely identified the problem. All the literature that we've read regarding this says that there's a pretty good correlation between socioeconomic issues and hereditary apathy. By that, I mean the parents maybe aren't involved. There's a lot of laziness, unindustriousness, that sort of thing. So there's definitely, we've outlined the problem here. The problem is, how do we get more kids engaged? And we've also identified a potential solution to this. By that, we mean Geogebra, because previous investigations into this have shown that Geogebra is engaging, and it might help our kids improve understanding of geometry. But unfortunately, we don't have any evidence because coronavirus ruined it all. So I just wanted to sum up really, and I've got 15 minutes left. I really just wanted to sum up what this investigation showed us, and basically trying to outline what we're trying to achieve. We all want to get from kids having poor mathematical attainment to kids having improved mathematical attainment. That's the goal. That's why we're all here, right? And our tool was going to be to use Geogebra. And I'd just like to outline some of the positives, some of the negatives that we found in this investigation. So I'll start off with the positive. Obviously, we haven't shown, but other people have shown that we've read, shown that Geogebra can be a vector for collaboration. So kids can really get involved, they can really become enthused about Geogebra, which is cool, and geometry, hopefully. Geogebra is an alternative traditional teaching method. So by that, it's a bit different. Maybe that's a potential reason why students become engaged, because it's a bit different. It's different to the usual chalk and talk. And we've also shown that, well, we haven't shown again, but we've shown that Geogebra is both accessible and adaptable. So, you know, everybody can access it regardless of socioeconomic status, that sort of thing, which is really cool. And now some of the negatives of our investigation. There's a lot of stuff we can't control. Now, obviously, this is the case throughout sort of educational studies, but there's lots of stuff that we can't change, which is unfortunate. And because coronavirus ruined it all, we don't have any primary evidence to support our claims. But what we've shown is good, solid method to investigate whether Geogebra improves mathematical attainment, and I'd like to see it continue. And here we go, end slide there. The big QR code is for our report. Scan it if you want, just a quick bang with your phone, you know what I mean? And those are our email addresses if you want to send us any hate mail. Thank you.